Hello friends, today I'm back again trying to sort of show you an exploit that has been used since last I guess 1 or 2 years. This is an exploit that's basically against AddJavaScript interface in the Android web applications. Rather than saying Android web applications, I should say just Android apps. Basically any Android application that uses WebView and uses AddJavaScript interface and is below I guess 4.1 or Android 4.2 is susceptible to this attack. In this case, basically you can use the reflection nature of Java. Basically what you're trying to do is by using AddJavaScript interface, you're allowed to create Java objects and they can be accessed in JavaScript. In this case, what I'm trying to do is use stored cross-site scripting. You can obviously use stored cross-site scripting, reflected cross-site scripting if the application opens up a specific URL, or in general do a man-in-the-middle attack against an HTTP response and insert JavaScript. In this case, this application is using Apache Cordova, which basically does the same thing but makes it easier. It's basically a hybrid application is what we call it. And by doing that, it basically introduces the AddJavaScript interface, which allows JavaScript to access Java objects. So this application is susceptible to a stored cross-site scripting, and that leads basically to basically exploit. In this case, I'm showing you a burp suite payload that I have created. Basically, I was able to bypass the script protection that this specific application was having by using script tags in a weird way. And as you can see, I'm just basically calling the navigator.notification.alert, which is one of the objects in Apache Cordova. However, the Apache Cordova does give out an object called Cordova native, and that's what I'm using to perform reflection. And so you can see I'm calling a runtime object, and by calling the runtime object at the end, I'm calling the exec method, and the exec method is basically calling a /system/bin/shell and trying to basically do an ls minus l and dump it into that specific application folder. In this case, obviously, you can open up a shell or anything that you would like to do, which the application has permissions to. In this case, I'm able to obviously write down right now the ls into a test file. So this is one of the places where the test file should be written. I want to make sure that there is no test file in that specific application. So here we go. So there is no test file in this specific application. I'm gonna send this payload again just to make sure that we send the payload correctly. Scrolling it down, and you can see that this has been written down over here as the way we expect. Now what I'm gonna do is gonna bring up the app, and then this is the page that's susceptible to this attack. As you can see, it popped up a JavaScript navigator alert saying process PID created. So that is what I wanted. Basically, I want to see now if the test file is created. And let's open up our WinSCP to see. Yeah, there it is, and the test file is created, and you can see the contents are filled up with basically all the stuff in the called by the ls command. So I have executed basically a system command and then done it using exploiting the AddJavaScript interface and basically adding the specific exploit. Again, the exploitation is possible because AddJavaScript interface does not restrict the reflection aspect of using the get runtime object, and that results into the specific flaw. Whenever you use AddJavaScript interface, ensure that you can restrict it to the specific methods that are allowed. I think above API 17 is where you will start seeing the annotation being set for certain methods by Android framework. In this case, before API 17, the annotations hadn't been set, and that's the reason this specific issue can be exploited. Thanks again. Appreciate your views.